Alright, so this one's going to be hopefully a shorter video than the other two because we're just going to build our intuition on velocity and acceleration and see how I can describe it verbally and how I can show it with a picture. So it's not going to be too much mathy, physicsy. It's just building our intuition on velocity and acceleration because I feel like a lot of people don't have that built into them. So let's say I have this number line, right? This is not a straight line. Let's see if I can use a tool. Oh, this is much better. I have this number line, right? Let's say this is where, let's actually just remove this end. So this is where time is 0, right? What happens if I'm here? It doesn't matter where I am, but let's say I'm here. This orange dot. And I'm just going to do this, so I'm going to say this is, anything in blue is velocity, and anything in, let's say purple. Sure, purple is an acceleration, right? This is like our little key, our key that will be, I'll just color code because it makes more sense, and then I'll put the dots as orange. Let's say I'm moving, my velocity is this way, right? Ooh, that was a straight line. So this is my velocity. And then let's say also my acceleration points in the same direction, right? What is happening to me? I am definitely moving right, but am I speeding up or am I slowing down? Remember, acceleration is change in velocity over time, right? So we're kind of changing our velocity by this much every second. So let's say 1 second later, I'm here. Our velocity is going to end up being longer than it is by this much, where how much a is compared to the length, right? So it's going to be this much, so let's say that's that much, plus a little bit more of what the acceleration is, right? That's our new velocity at this point. And our acceleration will be the same, right? I'm just going to say we're going to keep our acceleration the same. And then this thing of adding like a little bit more every single second will be the case for this kind of graph. If I were to continue, maybe I'd be here instead, right? So that's our first one. The second line that I want to look at is, I don't want it orange. See, I want it this color. Maybe this one might be better. Ooh, it does. It has a line built in for you. Let's say like this. I'm the orange dot. Let's move me here. I'm going to give myself a huge velocity, but I am giving myself an acceleration that points in the opposite direction. That's kind of interesting. So this is that every dot I draw will be 1 second, so I'll be here. How will my velocity compare? Will my velocity be getting bigger or is it getting smaller, right? Since acceleration points in the opposite direction, I'm kind of slowing down. It's kind of like deceleration, if you want to think of it like that. When you're putting your car at a high speed and slowing down, the A is pointing the other way of how you're moving. Even though you're moving right, you're slowing down because the acceleration's left. So maybe at this point, my velocity is just a little bit less, right? Just a little bit, right? This is a long line, this is a shorter line. How much less? How long is this, right? Let's like pretend we moved it here, right? We take away this much, we chop our velocity, and that's our new velocity. That's how I like to think of it, right? And then we continue that pattern. Maybe I'm here at time 3, right? So maybe I'm here and my velocity is this much instead, right? I chop off like this much about. This is a key thing that I feel like a lot of people don't actually pay attention to, but this is the key thing. When, let's say, when V and A, I'll bring it closer here. When they point, here, let me do it, V and A, so this is the condition. When V and A, this is the first one, point in the same direction, right? It could be going both right, going both left. I am speeding up. This was our first example, the first one that I did, right? This first diagram here, right? They're pointing in the same direction. I'm getting faster and faster every single time. When they point in opposite directions, I am slowing down. This distinction is kind of often neglected because people don't really understand what acceleration is, right? So sometimes in questions on tests, maybe like the AP exam, I remember getting asked a bunch of things, something similar to this, right? But instead of a picture diagram, they might give it to me as a picture diagram. It ends up being something like this. Let's say V is positive and A is positive. Am I speeding up or slowing down, right? They're both the same side, so they're speeding up, or accelerating it. Well, not accelerating. Anything with accelerating is accelerating in general, right? So I can't say, yeah, I'm accelerating faster, because there's already an acceleration, kinda, so I am speeding up is more of the correct terminology. If V is positive and A is negative, right? I'm slowing down. What happens if V is negative? I'm moving left and my acceleration is moving right. Even though I'm moving in the negative direction, I'm still slowing down because my acceleration's actually in the opposite direction, right? And then finally, the final case is my thing is negative and my acceleration is negative, right? That's kind of weird. Negative numbers don't really feel like it should be speeding up, but they are, because they're pointing in the same direction, right? My acceleration is negative, so every second my velocity gets even more negative than it already is, so it's speeding up. This is the summary I would like to show you. This is the summary of the whole thing. I would like to think about it being the whole thing. They can kind of deceive you sometimes in saying that, oh, I'm moving left though, and yeah, but my acceleration is moving right. I have to be slowing down no matter what, because I'm moving left initially, right? Let's say, I'll give you one quick example and then we'll stop here. Let's say I'm moving at 7 meters per second and my acceleration is minus 3 meters per second squared. See how they're opposite signs? Right? That means the very next second, so this is at, let's say at t equals 0. That means at t equals 1, my velocity is 4 meters per second, and my acceleration will just stay the same, right? This is at t equals 1. Notice how I slowed down my speed because it's opposite sign. That's like the first case. What happens if it's, let's say -3, and my velocity is -3 as well? Right? They're the same side, so we're speeding up, right? Speed is different from velocity. We're increasing our speed because it's the size, the number, the absolute value of it, right? So this is at t equals 0. At t equals 1, I'm speeding up to this. And my acceleration is still the same. So look, if I took the absolute value of this is 3, and this is 6. I'm speeding up, I'm getting faster. That means next time I'll be at -9 meters per second. I'm speeding up because they're pointing in the same direction. So that's a topic I feel gets often neglected, and a lot of people get confused when looking at acceleration, but I hope this diagram and this explanation is helpful in thinking about acceleration and velocity visually as well as mathematically.